Hello. Today I want to talk to you about how we started and how we got started with this whole thing. The first thing we need to know is our goals. So my goal in this whole project was to provide a product or a thermal barrier that would give us a overall assembled U factor of 0.29 or less. Secondly, it had to install the same as current products. We didn't want any learning curves for anybody how to install a new product line. We also wanted it to look the same, so when it was installed you couldn't tell our product from somebody else's. We wanted to use aluminum so that we'd have the same sharp corners and the finishes that we come to expect in the industry. And then we wanted to make sure that the cost was in line with current products on the market. I wanted to be within a 5% cost factor. Those are incredibly important. And lastly, I wanted to make sure that whatever we developed was transferable to other product lines such as unitized and window wall and windows. So that was our goal starting out. And then had to find a product to use. So I chose a pressure bar curtain wall to start with. The reason I chose that product was because it's something that I know very well. It's also a common product used on a lot of buildings throughout the country on low to mid-rise size projects, and it's like I said, it's a common product and it's used on the majority of buildings throughout the country. So I felt it was a good product that we could start with. So those were the reasons we started and why I chose the product that we did. And then lastly, I know I needed to find a third party to perform the thermal simulations and physical testing. I wanted to make sure that everyone knew it wasn't me, it wasn't our company, but it was a third party that was going to do all of the simulations and the actual testing. So with all that in mind, here's where we started. I had to find a baseline. Original baseline, if you look at this, I used a 1-inch overall piece of glass with a 1/4-inch clear exterior light, low on number 2, 1/2-inch airspace, 1/4-inch clear on the inside with aluminum spacer. That was pretty common 7 or 8 years ago for glass that was being used in the industry. It had a center of glass U factor of 0.291. But the system, when it was simulated, came in at 0.45. This is a delta, and this is what we call a delta, between center of glass and assembly of 0.159. This is why we have to take the frame into account when we look at U factors on a building. You put a piece of glass into a frame and the value decreases. So I knew in order for us to get to the 0.29 or less, we had to improve the glass somewhat. So on the improved baseline, you can see where we added in argon instead of an air spacer. We also used a warm edge spacer around on this particular improved baseline. So the center of glass was at 0.247 and the system U value came in at 0.39. Again, this did improve the delta somewhat to 0.143, and as you can see from the frame temperatures, they did improve somewhat from the original baseline to the improved baseline. But the 0.39 assembled value still doesn't get us to the current code requirements in ASHRAE zones 4, 5, and 6. So we knew we still had to do improvement. So here ultimately, when we got done, we developed the FreMarq thermal barrier and put it into our pressure wall system. And if you look at our values, the center of glass is 0.247. It's the same piece of glass we have an improved baseline. Well, I decided to use this piece of glass in everything we move forward with, whether it's unitized or fixed windows, no matter what system we look at. This is our glass type that we go to on every simulation. This way we're apples to apples. There's no fudging the glass. This is the same glass we use on all of our simulations. The system U factor with our FreMarq thermal barrier is 0.28. This is a delta of 0.033 between the center of glass and overall assembly. This hit all of our goals. It gives us incredible performance. The cost was within line of where we wanted it to be. But you have to ask yourself, even if it costs more, can you afford not to put this in your building? This performance should be in every building in the country if we are going to make a difference in our carbon footprint. This type of performance is required. No longer can the old systems be relied upon to give us the thermal performance that we need. So I have, again, with our thermal barrier performance, look at the frame temperatures. Now, the exterior, when we do a simulation, the exterior temperature is at 0. Interior temperature is at 70 degrees. We're at 63.5 degrees on the interior of our frame, compared to a standard system of 52.5 degrees. I mean, the interior comfort of sitting next to our system is incredible compared to an old system, compared to somebody who doesn't have this technology. The other point I want to make is in condensation. I mean, we run dew point analysis where we can do minus 20 on the exterior and we do 70 degrees interior with relative humidity of 50%, and we still do not get close to the dew point. We are well above the dew point with our interior frame temperatures. So condensation is no longer an issue with our product. With the standard product, you will have condensation. Potentially the glass, because if you look at an improved baseline, I think the frame is affecting the performance of the glass. The glass is at 47.6 degrees. It's 54.7 in our system. Again, same piece of glass, same glass makeup, better performance. So, this is where we started. This was our beginning. As I move forward, I'm going to talk more about edge of glass performance so that we all have a better understanding of new technologies like vacuum insulated glazing. The other thing I'm going to touch on will be things like unitized curtain wall, how we all perform everything on the market with the same thermal performance. And as we move forward, we will also be talking about cost and how we've brought the cost down in our systems. So again, this technology should be in every building in the country if we are going to make a difference in our carbon footprint, if we're going to make a difference in changing the climate, reversing climate change. This has to happen. Buildings are a huge factor in our carbon footprint, and this helps us reduce that. You know, you have a well-insulated wall, but yet then you put in a window that has an R2 or an R2.5. Why do that when this is available? Okay, so again, this is where we started. This is how I knew we could make a difference and how we could make an impact. And I look forward to continuing this discussion with you in the future. Thanks a lot. We'll talk to you soon.